This is Lesson 2, Part 2 on Firewall Fundamentals. It covers protocol analysis. The functions of a protocol analyzer. Why analyze data packets in the first place? We do it to detect network problems such as bottlenecks, detect network intrusions, check for vulnerabilities, and gather network statistics. What does a protocol analyzer do? It captures and decodes data packets traveling on a network and allows you to read and analyze them. Network-Sec-Ch02-P02 is a protocol analyzer. It's threat analysis software, captures raw packets from wired and wireless interfaces, and analyzes real-time data throughout the 7 layers. It filters by media access control address or MAC address, IP address, user, and more. Supports Internet Protocol version 4 IPv4 and Internet Protocol version 6 IPv6. Gets daily threat intelligence data from the SANS Network Internet Storm Center and is freely available. Wireshark is another protocol analyzer. It's a network protocol analyzer, and you use this in Fundamentals of Information Security in that class. It captures Ethernet, IEEE 802.11 packets, PPP, HDLC, ATM, Bluetooth, USB, token ring, frame relay, and FTDI and other packets. Analyzes real-time and saved data. It runs on Windows, Linux, OS X, Solaris, FreeBSD, NetBSD, and a whole lot of others. Supports IP version 4 and IP version 6 and allows voice over Internet Protocol analysis and is freely available. Here's a diagram describing packet capture using NetWitness Investigator. It selects the parsers to use with capture, geolocation IP, GeoIP, search, flex parse, then defines the rules for capture, including filters and alerts, verifies capture configuration settings, the network adapter, advanced capture settings and evidence handling, and then starts the capture. Trace analysis using NetWitness Investigator. Navigation, you select a collection, you click navigation, you select a report, you select a group of sessions, and search for specific content. When you do the search, you open a collection, click the content search icon, and key in a search. You can search on a keyword or a regular expression. TCP/IP transaction sessions. They're connection oriented. The sender breaks data into packets, attaches the packet numbers. The receiver acknowledges the receipt, lost packets are resent, reassembles packets in the correct order. Here we see a diagram of the TCP three-way handshake, where first the SYN packet is sent, which stands for synchronize, and acknowledge, of course, stands for acknowledge. The host sends a SYN to the server. The first system sends a packet with a SYN flag set. The second system responds with a packet that has SYN and ACK flags set. The first system responds with a packet with the ACK flag set. The two systems have now started a session. To terminate, you have an acknowledge packet and a fin, or finish packet. Because a TCP connection is two-way, it needs to be torn down in both directions. The TCP connection termination process uses 4 packets. The first system sends a TCP packet with the acknowledgement and fin flag set requesting termination. The second system sends an acknowledgement response. The host then sends a packet with the acknowledgement and SYN flags, and the server sends a packet with acknowledgement and fin flags set, and the host sends the acknowledgement back to the server. To reset a connection. Sometimes the host may need to terminate a connection quickly due to a port being unreachable or a timeout, for example. Here you have your synchronize SYN, the acknowledgement ACK, and the reset RST. So you can send our RST packet to the server. Initial SYN packet should never have the finish or RST associated with it. It indicates an attack or malicious attempt to get by your firewall. Network protocol examination. A normal packet connecting to an FTP server. Port 53 DNS and UDP or a three-way handshake completes it. A packet showing evidence of a port scan would be a series of TCP packets, part of a three-way handshake. They arrange the segments in sequential order by source port. The destination ports are also in sequential order, and this is a classic TCP port scan. Clear text versus encrypted protocols. Clear text protocols are human readable, such as FTP, Telnet, Simple Mail Transfer Protocol, SMTP, HTTP, the Post Office Protocol 3 or POP3, Internet Message Access Protocol, Network Basic Input-Output System, NetBIOS, or Simple Network Management Protocol. Encrypted protocols are not human readable. These are Secure Shell SSH, SSH File Transfer Protocol, which is SFTP, and the HTTP Secure HTTPS. This is the end of the protocol analysis slides in part 2.